Hi, in this video, we want to continue looking at some pandas basics. All right, so main thing we're going to look at are some plots, and then we're going to look at dictionaries, which are a special type of data in Python. All right, so let's go ahead and start running through code, and let's see what happens. All right, so first and foremost, of course, I set up my working directory. Now I'm going to import pandas, and I'm pressing F9 on my machine using Spider to make sure that's loading or run each line of code. And you can see down here that's running. Now, if I go down here, remember I need to highlight if I want to run line by line, everything that I want to run. All right, so now I've got the data set loaded. Let's take a look at the columns. All right, so take a look down here on the lower right-hand corner. You can see that I've got some space here, like I've got space between grade and 2012, grade and 2011. You'll notice that I've got some percentages in here. I've got some hyphens, and there is a slash here. All right. In general, when we start naming things in programming, it's best if we can avoid having spaces, tabs, punctuations in our names. So, looking through here, I've got a bunch of that. All right, so I don't want white space. White space is like spaces, on the space bar, and tabs and empty lines. Then punctuations are a special type of character that might get interpreted as something different. So a hyphen, Python might think it's a subtraction symbol down the road if I'm doing something. So in general, in data science, we want to avoid white space, and we want to avoid special characters in our names. So what I'm going to do on this next one is I want to go through, and I did this before I made the video, I replaced all the spaces with an underscore, and I went through, I removed the percentages, and I replaced the hyphens with underscores also. So now this is a more informative way. The way it is right now is a better presentation for humans to read. But as I start working through things, a lot of times I'm better off with having it with underscores. It's not as big of a deal in Python as it is in R, but it's good practice just to not have any of these issues going on. So what I'm going to do, so you notice that to get all of this to print up, I called the columns attribute of school grades dataset. All right, so to overwrite that, to replace it, what I'm going to do, I'm going to take the same number of items I have from here, and I'm going to make this list. You notice I've got an open bracket. Then I have a closed bracket down here. All right, so I'm taking what I want, and I'm taking the number of items I have in school grades columns, and I'm going to overwrite all of them with this one highlight statement once I run that. All right, and let's double check to make sure it did what I wanted it to do. So I'm going to go ahead and just print school grades column attribute. And it looked like it went through. Take a quick glance at it. All right, so you'll notice that that's an index. The column names are an index because I can call data using it. And it's classified as an object because each of these are character strings instead of being like a decimal or an integer, a number. All right, so anytime I want to overwrite specific properties, one thing I can do in Python, and this is true in R also, is I can call the item I want, and I just set equal to how I want it to be instead, which is very nice, very convenient, very fast. All right, so now I want to take a look at ways to plot using matplotlib, some quick and easy ways. All right, so how I'm going to do this today, and Python has a bunch of ways to do plots. This is just one particular way to do it. This is, I think, a good introductory way to start plotting. So what I'm going to do, I'm going to just take my data set, and I'm going to put .plot at the end of it as a suffix. And then I'm going to specify what do I want particular things to be. So like here, you can see I want the Y to be percent of total points possible, and X to be the percent of economically disadvantaged students. Okay, so first thing I'm going to do, I'm going to load matplotlib.pyplot. Now I'm going to go ahead, I'm going to run the whole thing. So remember, when we do a plot in Python, it goes in layers. First layer is the school grades.plot layer. Then the next layer is going to be the X label, the X axis label plot. And then the Y label, Y axis label will be my last layer. And when it goes from bottom to top, the most recent thing goes on top of previous items when I do this layering of graphics. So press F9, and notice I'm highlighting the whole thing as I do this. When I do that, oh, well, what is this? This doesn't make any sense. This is crazy. This is crazy. All right, so by default, Python likes to do line plots. I don't really like this. This is something I think is kind of like a detractor from Python, but whatever, you know, it's all good. It's not that big of a deal. What I need to do, I want to put down dots instead of lines because lines don't make any sense for this data set for what I've got. So if I was doing a time series, this would make more sense. You know, if I was looking at maybe like stock data, but I'm not looking at stock data. I'm looking at something different. So what I'm going to do, I'm going to do the same thing, but I'm going to put scatter for the kind, because that's the kind of plot I want is a scatter plot. Everything else is pretty much the same. So let's see what happens. Oh, okay, so now this makes a lot more sense. So I can see for each school, in the school grades file, I've got a dot. Along the x-axis tells me the percent of economically disadvantaged students. That's the percentage of kids on free or reduced lunch. And then here, this is the percentage of, oh, hey, oh, this is messed up. This is screwed up. Oh, no. I'm so embarrassed. I want Y to be the percent of total points earned. So I've got it correct in the plotting, but I don't have it correct in the label. So I am so embarrassed. So I'm going to fix it right here, right now, real quick and easy peasy, lemon squeezy. There we go. And hit it. All right, yeah, no, that's better. That's better. And make it a little bit better. It's best practices to always put on a title, but I don't want to get things too crowded. This is a kind of small area. If I was showing this to an audience at work, I would go ahead and change that up. All right, that is better. Or fix it here too. All right, and we can see like overall there's a negative trend as I go from left to right. You know, if I kind of imagine there being kind of like a line that kind of averages this out, it's going downhill as we go from left to right. And you'll notice that there are a bunch of dots like crowded on this 100% range. These are schools where all children, or all students are receiving probably free lunch, maybe reduced, but usually it's going to be free in these situations. Now, let's take a look at box plots for a second. All right, a lot of people are scared of box plots. You should not be scared of box plots. A box plot represents a 5-number summary of your data. It's a 5-number summary. All right, what are those 5 numbers? Minimum, first quartile, median, third quartile, maximum. All right, it's 5-number summary. All it is, it's a visual representation of 5-number summary. All right, so now something to think about. If it's a summary, that's not all the information, but this is a lot of information for only using 5 points. So what we've got going on, so for the moment, pretend that this little whisker thing is the minimum. This is the maximum value. And here, this is the first quartile, the median, and the third quartile. All right, so pretend these dots aren't here just for a second. I'll talk about those in a moment. All right, so how we interpret the box plot is that I'm going to think of this as being the minimum for all practical purposes. It's the minimum. There's a few outliers below it. This is the middle value of the data. So I'm thinking, if I was to line up all my data in a line, and I was to like go, let's see, minimum, maximum, second from minimum, second from maximum, third from minimum, third from maximum, and I kept on doing this like that, all the way in the middle would be this little green value, that green line, that's called the median. That's my middle value. That is a measurement of central tendency. Some people will say average. People get fussy about what is the average. I just say median, just be precise. Now, this value here, running over this way, it's like something around a little bit more than 50 by my eyeballs, is that this is the middle of, so if I take the minimum value and the median value and I go like this with my data after it's lined up, the point that's in the middle of those is the first quartile. All right, now, if I go from the median to the maximum, and I've got the values lined up, and I go, I go from, first from the median, first from the maximum, second from the median, second from the maximum, third from the median, third from the maximum. I keep on doing this. The one that's in the middle is the third quartile. All right, so what does this tell me about the data? All right, so this box, this is the middle 50% of my data is in that box. So I can see that maybe, let's say 65, and let's go maybe about 50-ish, something like that. So about 50 to 65 is where approximately 50%, the middle 50% of the data is contained in that range over here. We can see that the middle value, the average overall, is going to be a little bit less than 60. All right, so that's good to know. That tells me the middle 50%, that is a measurement of the central tendency. Where it's like the middle of the data. All right, so I mean, this is important. If it was like around 5 or around 95, those are going to be very different data sets, especially since we're talking about percent of total points possible. It's percentage. Now, up here, think of this as just being, for all practical purposes, the maximum. I can figure out what the maximum value is. So it's around 95 for all. And then the minimum value, let's say 25-ish, something like that. Can I eyeball it? Now, why do I have all of these dots here? These are what the system is calling outliers. Now, an outlier is just a value that is farther spread out from the rest of the data than we would expect. So it's going, hey, this might be something, there might be an issue with this. This might be farther out than we expected. When we get points like this, usually when we're doing data science, we just want to take a look, hey, is that a correct value? Was it recorded correctly? Was there a bad measurement? Was somebody drunk when they were entering the data? I don't know. But usually what we want to do, we just go in, we try to confirm that these are good, solid values to use. If we confirm that they're good, solid values, we don't do anything about it. If we can't confirm or deny, we usually just leave it alone. But sometimes we're like, hey, whoa, something's wrong. And we either omit the value or we replace it with one that is more reliable. All right. The reason why we like box plots is because if I have multiple populations with like comparable data, I can see, do we have different central tendencies? All right, so let's say we're talking about male and female, bench press strength. And so if I was to go through, I was to have box plots, the middle 50% for the guys would be a little bit higher than the middle 50% for the women if we were measuring bench press strength, for example. And so when I look at it, I would see that the boxes don't line up. If the boxes look like this, they're next to each other, then I say, hey, they're probably, the central tendencies are probably equal. If they're like this, they're probably different. You see how horizontally they don't smack into each other. And we'll look at some more box plots in a moment. All right, so now let's take a look at histograms. Histograms are a type of bar plot that shows me what is the distribution of the data. Let's go ahead and highlight it. And you know what? I do not need. working this as I go. There we go. Hit F9. All right, so it's made up this bar plot. We can see that on the very, very low side, there's very, very few. There's, you know, to my eyeballs, nothing between 10 and 20. Now, 20 to 30, there's just a sliver. Now we have an increase at 30 to 40, 40 to 50, even bigger. 50 to 60 looks like, hey, that's where most of the schools are landing. Now we have a decrease. We have fewer going between 60 and 70, decrease again, 70 to 80, 80, 90, even fewer. And then there are some that are in the 90 to 100 range. So here I have an idea of how common it is. So I can see that it's pretty common for a school to have between 50 to 60% of their students or of their schools getting that percentage of points earned. Kind of interesting. Now, but look here, when I do my plot for this for a histogram, I need to put kind equals to hist. Makes sense. Number of bins is 10. All right, well, I can change that number. Let's see what happens when I put down 2. Hit F9 again. Oh, hey. So here we can see if we split it into 2 groups, split it around 50, we can see that there's a lot more with above 50 than below 50. But, you know, this isn't very informative. Let's do this. Let's go 100 bins. What happens? All right, so now it gets really, really fine. I can see a lot of detail, but this looks pretty jagged. So 100 is probably not the best way to go. Let's try 20. Let's try 20. This is exciting. Let's see what happens. All right, that's looking pretty good. So when I look at my histograms, usually I don't want to see like the up and down that we're getting. So if I go back to 100, highlight, press F9. You see how I've got bars going up, down, up, down, up, down, up, down. That's a sign that I've got too many bins going. Too many, too many. Here I'm going with 20 bins. And, you know, I can see it goes up and then it goes down and it just keeps on going down, going down, going down, going down. That's pretty good. And over here, there's a little bit of bump, but it's so small, that's all right. So I think this is a pretty good number of bins. I've got an idea of what the distribution looks like. I don't think this is a normal distribution. I think that, you know, there's too many on the right-hand side. I mean, I wouldn't go far enough to say it's skewed, but, you know, I don't think it's normal. I think that this is close enough to a bell curve for a lot of purposes in hypothesis testing if I need to do that. But I know it's not, you know, a true bell distribution. Okay, well, what happens if I take the entire data set and I just do .hist on it? What happens? Let's see. This is going to be exciting. Give me a surprise. Oh, hey, look at that. All right, what it did, it took every single numeric value data field that we have, and it made the histogram. So I can go through and I can kind of look through and see what all is what. So let's see, that looks kind of normal. That's definitely not normal. Neither am I. Just going through, got all these values. That looks like a binomial distribution to me. I think that is school type. 1 is elementary, 2 is middle, 3 is high school, 4 is other, like a mixture. That's definitely skewed right. Here we got bell curve. Here that's, you know, definitely skewed. And I kind of get an idea of what's going on. But I've got so many values being plotted at the same time, so many different variables, that it's super crowded. I can't really make out what's going on. This really isn't a good way to go, but we'll get more into plotting later down the road. But I just want you to know that that's available. And if you need to for work, make a plot like this, you know, check the help documentation, reach out to me, whatever, and, you know, see what we can do to improve that. Okay, well, now let's take a look at doing box plots with multiple variables at the same time. So when I do this, I'm doing, once again, .boxplot, but this time I want to do the English language arts scores as box plots, I'm going to have 3 box plots at the same time. Let's see what happens when I do that. Okay, so when I do this, you can see I have 3 different box plots. So here, this is English Language Arts Achievement. This one is English Language Arts Learning Gains, and this is English Language Arts Learning Gains of the lowest 25% of students in the school. Okay, so we can see that these two are, their central tendency is the same, but this one is a lot more spread out. You can see that the box goes over a wider range here than this one. And we can see that the maximum value, minimum value covers a wider range than the practical, for all practical purposes, the maximum and min here. We can see that there's some points that might be outliers. Want to take a look. And over here, we can see learning gains of the lowest 25. Now, you'll notice that this box is like positioned a little bit lower than this box. So we want to ask ourselves, do we think that these have different central tendencies? All right, how we usually judge this. If I see this line going over, and if I go horizontally from the line and it cuts this box, and I go horizontally from the median line and it cuts this box, usually they're going to be statistically equal to each other for their averages most of the time. So for a hypothesis testing point of view, these 2 central tendencies are probably the same. Now, I'm looking at the spread. If I was to do a hypothesis testing on the spread of the data, then these are probably going to be different from each other. All right, now something I wanted to talk about previously, but I just forgot because I'm just getting old in my old age, is dictionaries. Dictionaries are a special type of data set where it's easy to go back and forth between 2 different values. So think about like states and state abbreviations. If I put down FL, that corresponds to the name Florida. If I put down Florida, that corresponds to FL. It's a back and forth. In Python, we store such relationships in dictionaries. This is something that R really does not address very well, but you know, R isn't perfect. But Python's got, this is one of the features that's really nice and makes things a lot easier when you need to go back and forth between values of data. Okay, so I want to make a dictionary. So I'm going to take 2 vectors of equal length, or lists, and see I've got state is equal to open bracket, close bracket, and I've got all these states. I've got capital, open bracket, close bracket, put an equal sign in between, and then I list out all of the capitals. Now, this is kind of a funny order to it. The reason why it's in this order is because when I was just messing around with it, I ended up sorting by either north to south coordinates when I was doing the data prep to get this copied and pasted onto the page, and just because I was the thing on the far left. So it's kind of a weird ordering, but it's all right. So hit F9. All right, so now this created state. And capital created this list of values. Now my dictionary, to create my dictionary, we've got curly braces going on. I'm going to take dictionary underscore state is equal to curly braces. Then I put the name I want it to be, the colon, the vector that I want to put in, capital, the name I want to be, colon, and then the values I want to be. So by putting in colon state, I'm taking all these values and I'm putting it in the column that is going to be labeled capital S state. By putting lowercase capital here, I'm calling this thing here, this vector, and I'm putting it into the dictionary underneath capital. All right, now, one of my conventions when I do my work is I like to name, if I have an object type, I will put the object type then what it corresponds to. So I'm putting dictionary underscore state. Now, when Python names a dictionary or the object class in Python, it abbreviates it as DICT. So let's go ahead and do that. And that's why I picked DICT underscore state. That way, as I'm working through things, I'm like, I've been working on something for hours. I'm like, hey, what is this? What class of object is this? Where did I get this? This will come up as you're working. I know what type of object it is so that it makes it easier when I need to plug things into functions. And the functions only take certain classes of objects. I'll know, beforehand if I need to change some features. All right, so now let's go ahead and print the dictionary. All right, so this really isn't very easy to read in this format. It goes state, then it lists it all out. You'll notice that it's the same as this, except it's actually printing out all the stuff I had for state. If I scroll down a little bit, see if I can find it. For capital, I've got capital, colon, and then it lists out all the stuff I put in here. Now let's take a look at what is its data type. All right, so dictionary underscore state is a dictionary. All right, well, let's make this into a data frame. Let's say down the road, I don't want a dictionary, I want a data frame. Maybe I want both for the project I'm working on. So I'm gonna go ahead and I'm going to drop it into a pandas data frame function. And I'm gonna call it data frame underscore state. So when I do this, I'm saying, hey, this is a data frame and it stores the state data. This is my personal convention. I find it works very well. Now let's print that. And there we go. This is much easier to read and I can go back and forth with it. So this format is easier for humans to read, but if I need to be able to go back and forth within Python, this is very easy for Python to handle. Either way, it depends on the problem that you're working on, which one's better for you. That's all I've got. So I hope you're staying healthy. Hope you're having a great summer and take care.